All right, today we're talking about section 5.4, solving compound inequalities. By the end of this video, you should be able to solve compound inequalities containing the word and graphing their solution set, as well as with compound inequalities containing the word or and graphing their solution set. You may notice some light jazz music in the background. You're welcome. All right, so example 1, solve and graph an intersection and graph the solution set. If I read this inequality to you, it says 6 is less than or equal to r plus 7, which is less than 10. So what I'm going to do is split this up into two inequalities. So I'm going to take that r plus 7 and I'm going to write it in two separate inequalities. So if I take the 6 is less than or equal to r plus 7 part, I'm going to flip that sign so it is greater than or equal to 6. Then I take r plus 7 and set it less than 10. Now I just got to solve for r twice. I'm going to subtract 7 from both sides. I get r is greater than or equal to -1. Subtract 7 from both sides, and I get r is less than 3. Now I have two inequalities that I'm going to set up on my graph here. I'm going to start with a number between the two. We'll start with 0. I'm going to count a couple numbers on either side. I'm going to graph both of these numbers on this line, so keep that in mind. All right, so r is greater than or equal to -1. I'm going to have a closed, closed dot on that number. Since it's greater than or equal to -1, I know this arrow is going to point to the right. It needs to point towards the bigger numbers. I'm just going to draw a mini arrow for now, and you'll see why in a second. R is less than 3. That means I'm going to have an open circle above 3. My arrow is going to point to the left, since it's less than. Now you see that my arrows are pointing towards each other. This is what happens when you have a compound and inequality, which is what we are just solving right now. So I'm going to draw a line that connects these two dots. There is my graph of this inequality. So the next example, now it's already split up for you. So -11 is less than or equal to y minus 3, and y minus 2 is less than or equal to -8. So I'm going to go ahead and solve each of these. So on the first inequality, I'm going to add 3 to both sides to get y by itself. -11 plus 3 gives us -8, which is less than or equal to y. Like we've talked about before, it may be helpful to you to switch it to have the y on the other side. Just remember you got to flip your sign if that's the case. You need your sign to still be opening to the correct number. Now I'm going to solve the other inequality. So I'll add 2 to both sides. I have y is less than or equal to -8 plus 2 gives me -6. All right, now I have my two answers. I'm going to go ahead and graph them. -7 is right in between those two. And I'll set up my number line like this. For y is greater than or equal to -8, I'm going to put a closed dot since it's greater than or equal to. For y is less than or equal to -6, I'm going to put a closed dot since it's less than or equal to. Oops. Less than or equal to. For this inequality, I know it's going to point to the right. It's greater than. For this inequality, I know my arrow is going to point to the left because it's less than. Because of this, I can just draw a line that connects these two dots. And there's my graph of this inequality. The next example, we have a word problem. It says a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. All right, so I'm going to let x equal the height of the action figure. All right, so my first clue is that the action figure must be at least 11.2 centimeters. All right, so remember at least means I'm going to have x is greater than or equal to 11.2. The next clue is at most 11.4 centimeters. At most means less than or equal to. So I have x is less than or equal to 11.4. Don't get at most and at least confused. It's a little difficult. All right. Now I'm going to rewrite this into a compound inequality. this is a little counterintuitive, but what I'm going to do here with this inequality, I'm going to rewrite it going the other way. So I keep that less than sign pointing at 11.2. Now you'll see that I have x's on the inside here. I can actually combine this into one inequality. So now I have 11.2 is less than or equal to x is less than or equal to 11.4. What's nice about this way of writing the inequality is now you see that the height of the action figure, x, is between these two numbers. So it's a nice way to write it. When I graph this, I put 11.3 in the middle, 11.2, 11.4. All right, for 11.2, I have a greater than or equal to sign on the original inequality, so I'm going to put that there. On 11.4, I have a less than or equal to sign. Again, this is a and inequality because it's between the two numbers. My line can just point between those two dots. The next example says to solve and graph a union inequality. So now we have this word or in there. So I'm going to solve each of these inequalities. I have b plus 1 is less than 4 and b minus 1 is greater than or equal to 3. So I'm going to subtract 1 from each side. So I have b is less than 3. On the other one, I'm going to add 1 to each side to get b by itself. So I have b is greater than or equal to 4. All right, now I'm going to graph these on my number line. So I have 3, 4. I'll fill in a couple numbers on either side. All right. Oops. All right, so for b is less than 3, I know I have an open circle there. And my arrow is pointing to the left because it's less than. For b is greater than or equal to 4, I know I'm going to have a closed dot there because it's or equal to. And greater than points to the right. So you might notice here that with an or inequality, our arrows point away from each other. That's a very important point to remember. So for or inequalities, the arrows point away from each other. They're not going to be a line drawn between the 2 points. All right. On this one, there's a little bit of a typo. So let's go ahead and change this to greater than or equal to. That will make it work out. All right. So I'm going to solve again each of these separately. So for 4k minus 7 is greater than or equal to 25. I'm going to add 7 to each side. So I get 4k greater than or equal to 32. Now I'm going to divide by 4. And I get that k is greater than or equal to 8. 32 divided by 4 is 8. On the other inequality, I'm going to get k by itself. So first I got to subtract 12 from each side. I get negative 9k is greater than or equal to 18. Now to get k by itself, I got to divide by negative 9. What happens when we divide by negative? Well, that sign's going to flip. So I get k is less than or equal to negative 2. All right, so now on my number line, I've got to go from all the way to negative 2, see if I can even fit all these numbers there, all the way up to 8. All right, k is greater than or equal to 8. I'm going to put a closed dot there for greater than or equal to. My arrow is going to point to the right. Oh, my dot disappeared. There we go. For less than or equal to negative 2, I'm going to put a closed dot above negative 2. Since it's less than, my arrow is going to point to the left. My next example, now I'm going to write and solve an inequality and graph the solution set. So in words, it says the sum of 3 times the number and 4 is between negative 8 and 10. All right, so I'm going to split this up a little bit. I'm going to split this up in half, and we'll focus on the first half first. So the sum means I'm going to add of 3 times a number. Times means I'm going to multiply. So if I have 3 times the number, it's the sum of 3 times the number and 4. So I'm going to add 3x plus 4. I know that this is between negative 8 and 10. So again, this is like an and inequality. I'm going to set this up to be between the two. The way we do that set up your inequality signs on either side, and then fill in the numbers. So now this says 3x plus 4 is greater than negative 8, and 3x plus 4 is less than 10. That ends up being between the two numbers. That's the way we denote that. So now we're going to solve this. Again, I split this up. I'm going to do 3x plus 4 is greater than negative 8. I just took that first part and flipped it around. Then I set up a second inequality. 3x plus 4 is less than 10. Now I can solve this. I'm going to subtract 4 from each side. I get 3x is greater than negative 12. Divide both sides by 3. I get x is greater than negative 4. Solve the next inequality. I'm going to subtract 4 from each side. 10 minus 4 gives us 6. Divide both sides by 3, and I get that x is less than 2. All right, so now on my graph's going from a little more than negative 4, or a little less rather. All the way up to 2. All right, so above negative 4, I have an open circle because it's just greater than. Above 2, I have another open circle because it's less than. Since it's greater than negative 4 and less than 2, I'm going to draw a line that connects the two of these. All right, the last part is to write a compound inequality for the graph. So now rather than coming up with a graph, we're going to write the inequality from the graph. All right, so on negative 9, pretend that this is on negative 9. It got moved a little bit, but just ignore that. Pretend this is on negative 9. I know that this is going to be greater than, since my arrow is pointing to the right. So I have a number that's greater than negative 9. Since the arrow is pointing to the right, it's greater than. The number here is negative 9. It's an open circle because it's just greater than. Now here, let's pretend this is on 2. My arrow is pointing to the left, so I know that x is going to be less than or equal to 2. Since it's a closed dot, it's less than or equal to. I can combine these into 1 since I'm showing something that's between the two numbers. So I'm going to flip this inequality around. Now we can see that I have x's in the middle. So I'm going to rewrite this as negative 9 is less than x is less than or equal to 2. Last one. Now we have arrows pointing away from each other. Now I know I'm going to end up with an OR inequality. So right here, this is the number negative 3. I know my arrow is pointing to the left. So my x, my number, is going to be less than or equal to negative 3. It's or equal to since that dot is closed. Now over here, my dot's at 6. My arrow is pointing to the right, so that means it's greater than. So now I have x is greater than 6. It's not or equal to because it has an open circle. When the arrows are pointing away from each other, you write each inequality and then stick an or between them. It's x is less than or equal to negative 3 or x is greater than 6.